In this video, we are going to study modulus function. A real value quantity x kept inside the modulus sign is called a modulus function. Its value depends upon the sign of x. If x is positive, then mod x is x. There is no change in its sign. For example, mod 2 is 2 or mod x square is x square for any real x. If x is 0, then mod 0 is 0. And if x is negative, then mod x is minus x, which means a negative quantity comes out of the modulus sign with a negative sign attached to it. For example, mod minus 2 will come out as minus 2 with a negative sign attached to it, and hence it will be 2. Or mod minus x square will be negative of minus x square, which is x square for any x belonging to R. In short, to get rid of the modulus sign, we have to focus on the sign of x. To solve problems involving modulus function, first we have to get rid of the modulus sign, without which we cannot go ahead of the solution. To do that, we have to deal with the legitimate sign of x. Let's see how this is done through many examples. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Modulus functions can be easily understood through their graphs. So let us first draw a graph of y equals mod x. When x is 1, y is 1. When x is minus 1, y is 1 here. When x is 2, y is 2 here. When x is minus 2, y is 2 here. When x is 3, y is 3 here. When x is minus 3, y is 3 here, and for x equals 0, y is also 0 here. So this is how we can draw a graph of y equals mod x. We can see the graph entirely lies in the positive region of y-axis or in the non-negative region of the y-axis. Talking of domain and range of this function, domain is set of all real numbers and range all non-negative real numbers. Shall we say modulus is a magical box that whatever real valued goes inside comes out as positive real. While this is graph of y equals mod x, it will also be the graph of mod minus x, and then this will be the graph of y equals minus mod x or y equals minus mod minus x. This is a graph of y equals minus mod x minus 2. If we put x equals 0, it will be y equals minus 2. The graph emerges from this point 0, minus 2 and behaves like y equals minus mod x as usual. This is a graph of y equals mod x plus 1. If we put x equals 0, y will be 1. Therefore, the graph emerges from this point 0, 1 and behaves like y equals mod x as usual. This is a graph of y equals mod x minus 2. To draw this graph, first we have to find its critical point by putting this x minus 2 equals 0, so that gives us x equals 2. Therefore, mod x minus 2 will be x minus 2 if x is greater than equal to 2, and it will be minus x minus 2, that is 2 minus x, if x is less than 2. We have to find this critical point for the simple reason that modulus changes its signs around x equals 2. When x is greater than or equal to 2, function is x minus 2, and when x is less than 2, the function is 2 minus x. Therefore, finding critical point is important. When x is greater than equal to 2, function is x minus 2. So when x is 2, y is 0 here. When x is 3, y is 1 here. When x is 4, y is 2 here, etc. Similarly, for x less than 2, function is 2 minus x. So when x is 1, y is 1 here. When x is 0, y is 2 here. When x is minus 1, y is 3 here. When x is minus 2, y is 4 here. Here domain is set of real numbers, whereas range non-negative real numbers, this and this. This is a graph of y equals 3 minus mod x plus 3. To find the critical point, we equate x plus 3 to 0. That gives us x equals minus 3, and hence y equals this 3. So the graph emerges at point this minus 3 comma 3 and behaves like y equals minus mod x plus 3 as usual. Its domain obviously is minus infinity to plus infinity and range from negative infinity to 3. Let us solve modulus equation mod 2x minus 1 equals 2. For graphical solution, we put y equals 2x minus 1, also y equals 2, and draw the graph of both these equations. Here we have drawn the graph of y equals 2 and the graph of modulus 2x minus 1, the graph in green. The points of intersection of these two graphs, 3 upon 2 comma 2 to the right and minus half comma 2 to the left, are the solutions this modulus equation. So graphically we can directly write the solution as x equals minus half and x equals 3 upon 2. We can solve them analytically also. So for that we put 2x minus 1 equals 2 and 2x minus 1 equals minus 2. This gives 2x equals 3, x equals 3 upon 2, and this one 2x equals minus 1 and x equals minus 1 upon 2, and y as usual is this 2 here. So the solution is x equals minus half and x equals 3 upon 2, and the points of intersection minus half comma 2 to the left and 3 upon 2 comma 2 to the right here. How to solve mod 3x minus 5 equals minus 3? We know that no modulus value is ever negative. Here modulus value minus 3 is negative. Hence this modulus equation has no solution. In other words, x is a null set. How to solve mod x power 2 minus 5 mod x plus 6 equals 0. Let us substitute mod x equals t. So given equation becomes t square minus 5t plus 6 equals 0. T minus 3 into t minus 2 equals 0. T equals minus 3 and t equals 2, which means mod x equals minus 3 and mod x equals 2. Here modulus value is negative, which is not acceptable. Therefore mod x equals 2 is the only solution which gives solution x equals 2 and x equals minus 2. Viewers, if you like this video, Please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.